All right, example 3 from the vertical circular motion lesson. So again, read the question, pause the video, come back once you've read it. So for part A, when it says at which point in the circle is the rope most likely to snap, remember we found out that tension is largest at the bottom of the circle. That was from the introduction video. And so that means at the bottom of the circle, the rope is most likely to snap. So what we know is if the rope doesn't snap at the top of the circle, or actually the other way around, if the rope doesn't snap at the bottom of the circle, then the rope will not snap at the top of the circle, because the bottom of the circle is where the tension is the largest. So for part B, we want to know if the rope will be strong enough to swing the rock in a vertical circle, a radius 2 meters at a frequency of 3 hertz. So what we're going to do, okay, is we're going to draw a circle, a vertical circle, and we're going to put our rock at the bottom of the circle, because if the rope's going to break, it's going to be at the bottom, so that's what I want to test. Now, at the bottom of the circle, okay, the tension force is towards the middle of the circle, and the force of gravity is down. And again, I'm drawing whatever force points to the middle of the circle bigger, because I know that the net force, or the centripetal force, has to be to the middle of the circle. So, like before, we know Fc is Ft plus Fg. Now, our job here is to find out what Ft is, okay? And the idea is when we calculate Ft, if we get a number that's bigger than 900 newtons, the rope is going to snap, because it says in the question that the rope will snap at 900 newtons. But if we get a value that is less than 900, the rope will not snap. So just be careful, we don't plug in 900 newtons for tension. We don't actually know if that's the tension. All we know is if that's the tension, the rope would snap. So what I'm going to do is I'm going to rearrange here for the force of tension. So we have Fc minus Fg. Okay, and I think I will calculate those. So like before, Fc is mv squared over r. And so m is 4 kilograms. V is, oh, you know what? I shouldn't have been using this formula here, because I just realized that the question doesn't give me the speed of the rock. Instead, it gives me the frequency. So I want to use the other version, this one here. So remember, 4 pi squared r over t squared, that's centripetal acceleration. And if you do mass times centripetal acceleration, you get centripetal force. So I'm going to calculate it this way. So, okay, so mass is 4 kilograms, and then we have 4 pi squared, and then r is 2 meters, and that's over t squared. Now I'm going to need t. So remember, t is 1 over the frequency, and it says the frequency here is 3 hertz, and remember hertz is the same thing as 1 over seconds. So 1 over 3, that's 0.3 repeating, and 1 over seconds is just seconds. So up here, this is 0.3 repeating seconds, and we'll square it. Okay, calculate that. Pause the video while you do it. Okay, so I've gone ahead and I've calculated Fc. Since I'm out of room, I'm just going to do it down here. So Fc is 2842.44 newtons. And remember, FC is always towards the middle of the circle. So the direction of FC, so when the object is at the bottom of the circle, towards the middle of the circle is up. Okay, so that's FC. Now we'll calculate FG. So FG is mg. So we have 4 kilograms times negative 9.81. So that's negative 39.24 newtons. And so now scrolling back up, so FT is FC minus FG. So FT is FC 2842.44. We're keeping FC positive because the direction of it is up. And we're subtracting from that FG, which is 39.24 newtons. That's negative though because it's down. And so for our final answer, we find out that the amount of tension acting in the rope is 2,881.68, and then the number keeps going newtons up. And so since this is more than 900 newtons, what we will say is that the rope definitely snaps.